Hello guys, in this video I would like to explain about biwavelet coherence analysis. Uh, and this video is about the theory behind biwavelet coherence analysis, and then there is some interpretation of the output of the biwavelet coherence analysis. In the next video of this series, I will explain that how you can create the plot which you can see on the screen for your data using R, a statistical programming language. We can use different libraries to create such type of nice plots in R, but this video is limited to the theory. So what is mean by biwavelet coherence analysis and why we need this? Sometimes we need to study the relationship between two variables. Normally, you can do that by correlation analysis if the problem is like the correlation in the correlation nature, and sometimes you can use regression analysis if the variables the problem is about regression analysis. There is a separate video on the differences between correlation and regression analysis. The link is given in the description of this video. So if you would like to know about the differences between correlation analysis and regression analysis, just hit the link given in the description of this video and you will see the detailed differences between correlation and regression problems. So sometimes you need to see the relationship between two variables, but you can do that by correlation analysis. But this technique will give you a detailed analysis in the time and frequency domain. So you can see the time is mentioned on the x-axis in each graph, and period or frequency is mentioned here in this. So this means that if your data is annual data, this means that the 4 years is here, and then this can be 2 years, something like this. So you can say this is short-term relationship, short-term, this relationship in short-term here. This is the period, and this can be 8 years. So you can consider this a long-term relationship, and this is with the time. And the bar is given for each plot, and this because this is a correlation problem, so this can give you a range from 0 to 1 and not from -1, because I will explain this later that why we don't need minus values here. So this video is about biwavelet coherence analysis, which can give you a detail about the relationship between two variables in time and frequency domain together. So this is a powerful approach, and mostly you can see people can use in research paper and data science and data analysis. So let's move to the theory that what is this technique and how you can explain this technique. Okay, this can be used in multivariate data, of course. So this is mentioned that multivariate data visualization and applications. So a biwavelet coherence plot is a visualization tool used to analyze the time frequency relationship between two time series. It is based on wavelet coherence, which measures the correlation between two signals in both time and frequency domain. If you are interested in wavelet coherence, you can see this is a separate topic. You can see the detail because in the background, this technique used the wavelet coherence. So this is a technique which can be used to study the relationship between two time series, or you can say two signals in both time and frequency domain. So this is the definition. Key features: time frequency representation display how coherence between two time series evolve over time and across different frequencies or periods. So you can see period is here. Maybe this is somewhere this can be a frequency, but this is period here. So time frequency representation, this represents the relationship between the two variables in time and frequency domain. So display how the coherence between two time series evolve over time and across different frequencies. Color coding. So what is mean by the color coding? Typically coherence values range from 0, no correlation, to 1, strong correlation or perfect correlation with warm colors, e.g. red, yellow, indicating high coherence. So this means that the deep blue color has very low coherence or no coherence, and then you can see it is increasing light blue, and then it's going to green, and then yellow, and then red, and deep dark red. So dark red means high coherence, that is mean. almost perfect correlation between two variables. And phase arrow. Now the arrows are extremely important in such type of plot. If you don't know about the arrows, then you do nothing about this plot, because the direction of arrow is quite important, very significant. Like often include to show the phase relationship between the two series is in phase or anti-phase. I will explain this in the next video, so I'm just left this to that. Application where you can apply this: climate and hydrology, assessing the correlations, the relationship between precipitation and temperature. Economics and finance, it is studying co-movement in stock market. And environmental science, you can use environmental science, linking climate drivers with river flow pattern and so on. So you can use this, a lot of application of this plot in various areas you can use. You remember that when you are studying the relationship between two variables, in that situation you can use, the correlation or correlation. In that case, you can use this type of plot. Okay, now I will explain about the arrows. So now this in the previous slide I said that if the variables are, if you don't know about the arrows, you don't know anything. So this means that yeah, okay. So if you don't know about the arrows direction, that you cannot interpret the results of this plot. So you can see I have mentioned this, because there is no clear trend, because the arrows are some moving here over there in some multiple direction. So I just made like this one in this direction, this one in this direction, this one in this direction, this one in this direction. There are four directions actually, in fact. But you can see that if generally I can explain that if the arrows are toward the right direction, like the arrows are in this direction, the arrows are in this direction in the right side, this means that the two variables are in phase relationship. Okay, the two variables are in phase relationship. And if the arrows are toward left side, like here in this direction, then this means that the variables are not in phase relationship or anti-phase relationship. And this means that if the arrows are toward, right upward like this, if the arrows are toward right upward, this means that the variable are in phase and variable one lead. That means variable one influence the second variable. Like in this case, AO is one variable and BMI is another variable. So in this case, AO influence the BMI. But if the variable are in this like right downward direction, the arrows are in this direction, this means that the relationship is still in phase, but variable 2 lead. This means variable 2 influence the first variable, like in this case BMI influence AO. Maybe you are not interested in this, but the situation is, you can explain in this way. And this means that if the arrows are toward left side, that means the variable are in anti-phase relationship. And if the arrows are left upward direction, the arrows are in left upward direction, this means that variable first lead the second variable. That means the first variable influence the second variable. But of course, anti-phase means negative relationship. And this variable, if the arrow's direction are left downward, like in this one, the bottom, left side bottom, this means that the variable are in anti-phase relationship. That means negative relationship, negative correlation, but variable to influence the second variable to influence the first variable. So this is the interpretation, and you can interpret your result just looking at this plot. You can interpret your results. So interpretation is quite important, and in some ways was difficult, but by plotting these arrows, this can make it easy for you that how you can interpret the result, the output of by wavelet coherence plot. And this is my own created plots, and you can see this is for annual average precipitation is the first variable in each pot, you can see, and then the crops or fruit production is the second variable. So I just wanted to see what is happening, what is the relationship between annual average precipitation and then the crops and fruit production like grapes, apricot, and sesame, and then jowar, and then barley, and then wheat. So you can see the relationship between these variables. I mean the annual average precipitation and grapes in the light of the interpretation which I presented here. So this means you can use these plots where you want to study the relationship between two variables, and particularly if you are interested that which variable influence the other, and this will give you a detailed result about the relationship between these two variables and time and frequency domain. One thing that I would like to explain that this is now the period, and you can see this is my data is annual data. So this means 4 years, this is 2 years, this is 6 years, and this is 8 years. So in this range, you can see the relationship is in short term, and in this case, in this area, the relationship is in long term. And this color bar show the correlation between the two variables. So 0 mean this mean low correlation, and this mean high correlation, the red color. And this the color which the area which is in the with the dark black line, that is the significant region, and you can use significant, that's 0.05 or something like this. And you can see this area at this time period, in this time and this frequency, there is no relationship between the two variable. And by the way, I said that you don't need negative values because in this side the correlation is positive if the arrows are in this direction, and if the arrows are in this direction, the correlation is negative. So in this case, you don't need any negative values because this can cover both. Because in this, if the arrows are in this direction like this one, this means that the relationship is positive. And if the arrows are in this direction, you can see somewhere here, I don't see here, but this I can see this one. This is some ways like left upwards. This means that the variable are in anti-phase relationship. There is negative, strong negative correlation. And by the way, variable 2 influence variable 1 in this case as per interpretation of this plot. So this is all about a bivalent coherence plot. And if you need further help in interpretation or whatever, you can write in the comments. And thank you very much, and see you in the next video. Ciao.